Friends, you know well, there are two types of waves, basically. Of course, three types. EM waves, matter waves, mechanical waves. The example of EM waves like X waves, gamma rays, radio waves, light. Like mechanical waves, sound waves, string waves. Matter waves like Debug-like waves. Now I am interested here for matter waves. First of all, if I am talking about a wave, so I have to write the wave equation. First of all, I have to write a wave equation. The wave equation like curly 2u upon curly x square. U is some parameter like displacement. It tells us about the variation of u with respect to the distance. Like this is a wave. Okay, this is a displacement. Let me call it u. At this point, this is u. At this point, this is the u. At this point, the u is there but in negative direction. That means the u, which is the displacement, it is continuously changing. So u is a function of x. So their double derivative, first of all, u, how it changes with x. You got some quantity because this is the variation of u with respect to x. You have some result like a. Now again we are having derivative curly a by curly x. That becomes this double derivative. Okay, how then a varies with respect to x? First of all, how u varies with respect to x? That becomes a. Then again how a varies with respect to x. That becomes the double derivative of u. And in case of wave equation, it is equals to double derivative with respect to time. Okay, with time, the displacement, this value, it also changes with respect to time. But these two variations, they are not dimensionally, they are not equal. They become equal with 1 over v square. Very simple. Because numerator they are same. In denominator it is L square. Okay. And here this is time. Sorry, curly du by curly t square. This is t square here. Now this is v square. V square means L square upon t square. And t square cancels. So L square equals to L square. So that means this equation is dimensionally correct. Now, if it is dimensionally correct, what about the solution of this wave? What is the solution of this wave? Okay. Now you can think about the solution like u is equals to a sine kx minus omega t. Because if you take the partial derivative with respect to x, again partial derivative with respect to x, you are having some left hand side. Again you take the partial derivative of u with respect to time. Again partial derivative of u with respect to time. Then multiplying with 1 over v square. Both become equal. That means u is exactly a solution of this equation. When we discuss some wave, maybe EM wave or matter wave, we have to write first of all the wave equation. And what the wave equation is? The wave equation is curly square u upon curly x square is equals to 1 over v square curly 2u upon curly t square. This is a wave equation, and it tells that u is a function of x and t. U varies with x, u varies with time. And now what about the solution of this equation? Solution, I meant to say, what is the expression of uxt? Let uxt is a sine kx minus omega t. K is constant and this is 2 pi by lambda. It is called a wave number. It is just constant depending upon lambda. Omega is angular frequency. U is a solution of this equation because if you take twice the partial derivative of u with respect to x, you will got some quantity on the left hand side. Then you take the partial derivative of u with respect to time twice. Then substituting the right hand side with 1 over v square, both the quantities becomes equal. That means this is a solution. This is a solution of this equation. Okay. Now I am having the second choice, which is much better than this. That is called a wave function. And wave function is written as psi xt is equals to a e raised to power a of tau kx minus omega t. Again psi xt is equals to a e raised to power a of tau kx minus omega t. This is also the solution of this equation. How? Take the partial derivative with respect to x twice. That becomes the left hand side. Then take the partial derivative with respect to time twice, multiplying by 1 over v square. Then that becomes the right hand side. Both will come equal. When both are equal, that means this is also the solution. But the main thing is this is better solution than this. You know why? Why it is better? Give the answer. Now because psi xt is equals to a e raised to power a of tau kx minus omega t. This wave function constructs a wave which becomes infinite in extension. This wave function tells us that the wave which we are having, it is infinitely long. It is, extending in the whole universe. But when you are coming, when you are discussing a particle, then the wave becomes wave means that the probability wave. And if the probability wave is extending in the whole space, in the whole universe, that means your particle is nowhere. This wave function tells a wave which is infinite in extension. It is spreading in the whole universe. Because when we talk about a matter wave, then material particle is having probability in some way. But in case of, if this is a probability wave which is in the whole universe, that means probability of the particle is having universe, it is everywhere, or you can say it is nowhere. So that means this is a limitation of this equation. It cannot represent a free particle. So then we are coming, how we say a particle wave, we should not be infinite in extension. Then we are taking the sum. We are having infinite waves, or I can say I am having a definite number of waves from 1 to n. If I take the sum of these all the displacements, so if I take the sum of all the waves from I equals to 1 to n, or it is better integration e raised to power iota ki x minus omega, so no need of I now, kx minus omega t, no need now I, because I am not going to take the summation. So this is integration. And dk with respect to k integration minus infinity to plus infinity. This a, actually it is also a function of k. Okay, better write a like a k. So that is the integration is with respect to k. Now I am integrating means the sum of all the waves which differs in a very small amount with respect to k. Now when you going for integration, then you will have a wave which will be of this type. Now it is very good. This is a probability wave. It represents a particle. That means I am telling that particle having maximum probability having in this region. But particle may have in this region, but there is less probability. May have here, maybe here, maybe here. When your particle will be in this region and having the probability, maximum probability of particle having is here, less is at the ends. But we are not saying particle now. We are saying a probability waves. This probability wave is a particle now, the whole wave. Because the probability, there is no definite where the particle is. It's not definite. So this is how the wave function, when you take the integration or you want to take the summation, then you can say you are having a probability wave which represents to a particle, which is for a particle. Okay, thank you.